rational and irrational numbers are two groups of numbers. Both rational and irrational numbers are real numbers. They can be plotted on a number line. The big difference between them is that rational numbers can be written as a fraction or a ratio of two integers, that is, two whole numbers. Irrational numbers cannot be written as a ratio. Now they're irrational because they can't be written as a ratio, not the usual meaning of irrational that means crazy or not making any sense. Now this definition probably seems quite irrational. It might not be making any sense yet. Let's have a look at some rational numbers. Obviously, if we can have a number that is a fraction, e.g. 1/2, obviously it's a rational number. It can be written as a fraction. A whole number, such as 3, or even -3. Any whole number can be written by a fraction if we write it over 1. So -3 definitely can be written as a fraction. We've encountered repeating decimals, 0.3 repeater, for example. But we know from previous lessons that that's actually just the fraction 1/3. So any repeating decimal is a rational number, because any repeating decimal or recurring decimal has a fraction that gave it. Other quite tricky numbers that are still rational. How about a terminating decimal? 1.5. But we also know that 1.5 can be written as 1 and, well, that's in the tenths column, is the 5 there, so that's 1 and 5 over 10, which would simplify to 1 and 1/2. Or even if we desperately wanted to write it just as a fraction of two integers, we could write it as an improper fraction of 3/2. So any mixed number is also able to be written just as a fraction of two integers. Any terminating decimal can be written as a fraction. So all these numbers are rational numbers. Even some square roots and cube roots are rational numbers. If I asked you for the square root of 25, we could check that on our calculator if we weren't certain. The square root of 25 says, what number did I square, did I multiply by itself to get 25? Now we know that the answer is 5. 5 times 5 is 25, but if we weren't sure, the square root of 25 is 5. So it's still a rational number even if it's a square root, as long as it gives a rational answer. So all of those examples are rational numbers. We can see how we can write them as a fraction. I'll just make that 5/1 there so we can see it's clearly a fraction. We don't need to be able to check every single rational number to make sure it can be written over a fraction. If we see a fraction of integers, an integer itself, a recurring decimal, a terminating decimal, or a square root that we evaluate and it gives us a rational number, any of those are automatically rational numbers. Irrational numbers can't be written as a fraction of two integers. So pretty much these are the non-recurring and non-terminating decimals. A lot of square roots and other roots are irrational unless they come out to a nice even or a nice round number like 5 here, or a nice rational number. So the square root of 2, let's find the square root of 2, 1.414213.562. Now if we don't see anything repeating, making a repeating pattern that keeps going forever in here, our calculator just cut off the end because it can't display any more digits than that. So that is, we can't write a decimal that keeps going forever as a fraction. The way we write a decimal as a fraction is, well, if we have, say, 0.2, a little tiny example in the margin there, I look at the fact that I have 2 in the tenths, and I put that over 10. I put it over the largest number that we would ever get to in the place values, or okay, the smallest. So if it was 0.25, well, 25 over 100. But I can't count the places to know how big my denominator would be if the places keep going forever. So I cannot put this number, the square root of 2, as a fraction of two integers. Another very famous example of an irrational number is pi. And it's got that symbol, we call it pi. You'll learn more about pi later. And pi is 3.14159.265, and pi keeps going forever. And since the decimal places in pi keep going forever and they don't form a repeating pattern, it's irrational. So, the sort of questions we're likely to get ask us to mark numbers as whether they're rational or irrational. So very quickly, how about pause the video, write down questions A through I, and try to work out for yourself, are they rational or irrational? You can use the calculator if you need to check the square roots. Oh look, we've already done root 2. It's irrational. There you go, a cheating one for you. So pause, work them out, start the video again. So you're back. I hope you've got some attempts at these. Let's check your working and your reasoning. 3 over 5, it's already a fraction. It's rational. -3, an integer, a whole number, even if it's negative, definitely rational. We know that root 2 is irrational. 0.3 repeater, it's a recurring decimal, so it's rational. 8 is a whole number, definitely rational. The square root of 9, if you couldn't think it through, remember what number multiplied by itself to give me 9? Square root of 9, 3. It ends up as a rational number. It's rational. 0.54, a terminating decimal, can be written as a fraction, rational. Pi, we definitely know pi, it's irrational. And this one, 2.71828, are we repeating? No, 1828 may be repeating, but no, we're back to a 4. We're not repeating as far as we can tell. Oops, I nearly made a mistake. Of course, our best guess is that it's irrational.